A photo of the robot up here, they're actually setting an excellent example of what I'm expecting everybody to do in this session, which is not stay in your seat. So that's rule number one. And you'll see why at the end of the well, not the end, but the middle of the presentation. Rule number two. So what do you do when you're when you're in a meeting and you want to ask a question? What's the typical protocol? So we're not doing that here. So if you have a question, just shout at me. My name's Steve. You can. Hey, how you doing? What's your name? Elon. Elon. Okay. Excellent, Elon. Do what Elon just did. Shout at me, call my name, and then I'll be happy to answer anything as we're going along. And we have a third rule too, but we'll get that later. It'll be fun. So I'm the Java community manager working for Oracle. My Twitter handle's Steve on Java. I also help manage the Java Twitter handle, so you'll occasionally see my stuff on there. Oh wow, that's going to be, yeah. Okay, we're going to have fun with the robot too later. You'll be happy to know that the robot has been recently tested. I upgraded it to a Raspberry Pi 3 at 2 a.m. last night. So this is a real hacking demonstration of what you can do with the very latest hardware and the very latest technologies. And hopefully you guys will have a lot of fun in this presentation. So how many of you guys know what a Raspberry Pi is? All right, excellent. You can all stay. Does anyone not know what a Raspberry Pi is? Okay, so thank you. So that was probably very embarrassing to raise your hand after you saw everyone else's hand go up. But here's what we're going to do. We're going to make one of those hundreds of people who just raised their hands help explain to you what a Raspberry Pi is. All right, so I'm gonna pick on Elon because we're friends now. It's that. Very good. Did that help? Do you know what a Raspberry Pi is? No, I'm asking the guy in the right shirt. But you already knew what a Raspberry Pi was. Your hand went up. Yeah. So that's an accurate description because this actually is a Raspberry Pi. All right, now Elon, which model Raspberry Pi is this? Oh. Okay, so the giveaway here is you see that little single USB dingle? Yeah. So it's Raspberry Pi Model B. It's either there were two revisions of Raspberry Pi Model B. There was one really early one where they kind of messed up the GPIO pins. And there was the cool second version, which has the same GPIO layout that we've all come to know and love. So if you unfortunately have one of the really early ones, your compatibility is slightly less good, although a lot of the libraries will compensate for that. But everything from the Raspberry Pi, the original Raspberry Pi B, through the latest Raspberry Pi 3 are all backwards compatible on the software stack, which for an embedded platform, this is basically unheard of. Has anyone here done like other platforms like BeagleBone or PandaBoard or maybe some Arduino boards? Arduino's actually pretty good in terms of compatibility, but they have different board revisions. Most of the other embedded boards are horrible at compatibility. If you write it for one board, you have to rewrite it, new firmware, new updates, just like start from scratch when you get a new platform. And starting from scratch on the Raspberry Pi is fairly easy, right? You grab the Noobs installer, copy it to an SD card, plug it into the Raspberry Pi, and then you're up and running in an afternoon. Most of the other platforms, I remember when Gary Collins and I used to work on the Java SE stuff, Java SE embedded in the really early days. And his whole job was just getting new boards and testing them, and you'd spend weeks getting a new embedded board up and running with all the bugs and the weird firmware issues and all that stuff. So Raspberry Pi is really modernized doing embedded board development, and it's quite a capable board as well. So the original goal of the Raspberry Pi was as an educational platform. So it's basically a $35 computer you can use in classrooms, and as a result, it has a full HDMI. It even has a component video. On the later boards, the component video is mixed in with the audio, so it's a three-prong jack. It has GPIO pins, which lets you interface with hardware. An SD card. The later versions, it uses micro SD. The really old versions, it uses a full-size SD card. Micro USB power. The amount of memory on these is now amazing. It started at 256, and now they're up to a gigabyte of memory on a small embedded board. So basically, anything you can run on desktop, you can run on these small devices. And you're also, with the Raspberry Pi 3, you have a quad-core 1.2 gigahertz chip, so it's also extremely capable. So it runs your software, and it runs it fast. And this is a great example board for doing Java projects. And in particular, Java SE. Most of the projects I'm going to talk about and show you guys are all going to be Java SE embedded. And of course, JDK 9 is Java SE. And that means you can take exactly the same code you're running on desktop and then run it on your Raspberry Pi. So what sort of projects have you guys been using your Raspberry Pis for? Anybody? Oh, solar power monitor. So that's a tough bar for the rest of the folks. Okay, so you don't have to have something that cool, but what have you done? License plate? Detector. Will it actually read?
Yes, we can recognize the place that it seems to be.
Oh. Nice. Okay, very good. Anyone else? We'll do one more. Yeah, go for it, man. In the black and white stripes, yeah. Like what sort of sports?
Not sports, dashboard, just power companies doing the different things, real time, like analytics for companies doing.
Okay, real-time analytics. So like a dashboard on a big TV, or?
Yeah, we have like 7 or 8 TVs, and some of them are for our support groups, and some of them are for our financial group, and it tells us what we're doing. So every department can see what every other department is doing at all times.
Okay, that's really cool. And that's interesting because it sounds like it's probably not your day job to work on the Raspberry Pi, but you found a way to integrate into what you're doing within your team. And that's one of the really cool things about small embedded hardware is it lets you take projects from the your software skills as a developer, where you're normally coding on computers and interacting with virtual things, and then move that to the physical world. Start controlling devices, start making use of power. It kind of opens up a whole new range of things which you can integrate with your software development skills. And hopefully most of you guys are Java programmers. So everyone who's a Java programmer, raise your hand. Okay, now if you've done Java on the Pi, keep your hand up. Okay, so quite a few. So very good. Hopefully I'll convince the rest of you that you want to give it a try. Okay, so Java 9 introduces lots of features into the platform, and I'm going to focus on a few of them which are particularly interesting on embedded platforms. So, biggest feature in Java 9, you probably heard about this, perhaps, from our chief architect Mark Reinhold. Java 9, modularity, and see, it's so synonymous with Java 9. I accidentally replaced modularity with Java 9. So that's how much this is a core part of the release. And it's composed of multiple JEPs. JEPs are our enhancement process. So all these JEP numbers, if you Google them and look it up online, you can actually see the original proposals for the different features. So you have a module system, the modular JDK, modular source code, so that's kind of the core. Modular runtime images is actually interesting by itself. So I'll talk about that a little bit. And then it also has encapsulating most of the internal APIs. So they basically restructured the code base into modules itself. And then jlink, which is a Java linker. And this also is extremely important for embedded devices. So, oh wow, you guys are going crazy. You're having way too much fun. Yeah. Okay. So this will be an entertaining test of the robot. I haven't tested in track switch crossover itself. But I think you guys asked me, and I said it was okay. So we'll go with it.
No time like production to test.
Exactly. Test in production. That's the, what's it called? DevOps way, right? Yeah. Everybody does it, but they don't admit it. Yeah, that's true. Very true, Elon. Okay, so the first one, modular runtime images. So basically the, jars and zips and, well, zips are really old. I remember using zips and didn't they have them back in the AOL days, like the really early dial-up modem days? Yeah, so this is what? Yeah, so this is pretty old technology. So they're finally going to actually upgrade the format for modules. So they're getting rid of jars and zips, creating a new structure for how they're orienting the modules. They're going to use better compression, which will give you better startup time and also make it easier to load resources quickly out of the modules. So for embedded devices where startup time is a big issue, this is actually a huge performance improvement for your applications by improving the file format for how things are going to be deployed. And it can also be extended to different data types in the future. So it'll open up a new way of packaging the libraries and stuff which you're going to be pushing to devices and hopefully give you a nice performance bump along the way. And actually, a lot of the improvements for performance are either going to fall in the category of size. So the module system in general will help you with building smaller applications and tailoring the JVM to the size of the application, or speed. So this is a little bit of both because the new modular runtime images are going to be smaller than the equivalent jars and zips. You save a little bit of space, but space is not at a premium on the Raspberry Pi. But probably what's more important is you save some time in startup. Okay, and this one is probably the feature which we've all needed on embedded devices for years. So has anyone used compact profiles on the previous version of Java SE? Okay, so yeah, nobody really uses it. We are going to have backwards compatibility for compact profiles if your application depends on it. But jlink is really the way forward. And this is a tool which will actually create a custom JVM runtime with just the modules and the classes that you need to run your application. And so this allows you to actually optimize a runtime just for the application and then have a very small executable, which is what you're actually going to be running as your application on device. So there's a lot of possibilities for this, especially on small embedded platforms. This allows you to run Java where normally it wouldn't fit, space-wise. It also allows you to save space on larger devices and will hopefully help improve startup time and performance, since you're going to be having less classes and less bloat to your application in the runtime itself. And anything which jlink spits out is considered a valid Java runtime that you can use with your application. So I think the way the licensing works on this is you're not allowed to modify the Java runtime yourself, right? So you can't arbitrarily go and modify it and publish a new version of the JDK, but jlink can modify it, and then if you can distribute that modified version with your application. So it's like you're creating a modified JDK just for your application. And then just for general usage, jshell is a really important feature because you can actually easily execute commands on the command line. So for example, if you wanted to test the GPIO pins on a device or you wanted to quickly do something on console, this lets you pull up a read-eval-print loop. So basically, you type jshell, you get up a prompt, and then you can type commands directly into it. And it gets rid of a lot of the ceremony around Java. You don't need a main class. You don't need all of the imports. And you can start directly using things. And then, similar to other scripting languages like Python, Ruby, then you can actually get a few things quickly done on the shell in Java without having to create a whole application and class to test it.
Will you be able to run Java as scripts like you can do with Scala?
Run Java?
As scripts. You don't have to compile it. You just upload something to use this API or something.
Okay, so the question is, can you run Java as a script, similar to how you do in that's a really good question. We can check the command line arguments to jshell later and see if you can pass it a file. It sounds like it should be possible.
It should be.
Yeah, it should be possible. I don't know if we're encouraging it or not, so we'll see. But I mean, REPLs are really common in different languages, so it's a really popular feature set, and Java just hasn't had it for a while. And this also makes it much more approachable to young coders. So students and kids and other folks who are picking up Java for the first time, it's fairly unapproachable to have all the ceremony around getting a main class before you even see your first result. So this matters to me since I teach a lot of young kids. Actually, the young kids are really good at this stuff too. They can build hardware better than we can. Okay, and the last main feature of Java 9 I'm going to call out, and you can check the full list of JEPs on the Java 9, the OpenJDK 9 website. But I think another one which is useful to mobile developers or embedded developers is the fact that we now have an upgraded HTTP 2 stack. So particularly if you're running like a web server, if you're accessing your device over HTTP, this should allow you to take advantage of the new HTTP 2 and WebSocket implementations and give you a better API and also compatibility with the latest standards. Okay, so there's also some changes under the hood that they're good, but they're also bad. And I'll go through those. So this is when you know, if you finish your breakfast and you have any fruit left over, just get it ready, and you can start tossing at me as a proxy for Oracle direction. So you notice those red marks on the screen there? Yeah. So this one here, not available, not available. So this is why I was upgrading my robot last night. I forgot that I had I thought it was a Raspberry Pi 2 inside because it had the 4 USB jacks. And I forgot it was one of my old B pluses I had on this, and I didn't actually have it on a compatible operating system. So the Raspberry Pi A, B, B plus, and 0 all use the older ARM version 6 processor. So basically all of your single-core Raspberry Pis. And those are in the not supported category. And I'll explain to you why it's not supported. There's a good part of not supporting it, and there's, well, the bad part you know already, because you can't run stuff on it. So the good part of not supporting is we upgraded the compiled Java binaries from thumb to thumb2 support. So in the ARM instruction set, there's, for 16-bit processors, there's the instruction set's called thumb. And it's somewhat limited because it's designed for 16-bit processors. So there's a lot of things where you have to use multiple instructions to get the same effect. So you end up with larger binaries because it's using more instructions and slightly reduced performance. So for backwards compatibility, the Raspberry Pi Foundation backported Debian Linux to a thumb architecture. So originally, the embedded Debian didn't work on thumb. It was only thumb2. That's why Raspbian works on the older chips, all of these Raspberry Pis. If you notice, Ubuntu, which also has embedded builds, they only support Raspberry Pis 2s and 3s for exactly the same reason. So they're targeting ARM version 7 and up, and specifically the new thumb2 support and some of the new instruction sets. So while it's awesome to be able to run on older hardware, the problem is there's a cost both in terms of more testing and more platforms to run on, and also running on an older processor set, older instruction set. So we made the decision to cut over and use the new thumb2 support, but that limits the platform to Raspberry Pi 2 and above. So if you're on an older Raspberry Pi, you're going to have to stay on Java 8 or compile your own binaries and then hack the code. So I'd recommend staying on Java 8. If you're on Raspberry Pis 2 and above, then you can take advantage of the new release. So a little bit of good and a lot of bad. So any fruit yet? Okay, this is where the fruit starts. Oh, no G1 garbage collector. So I believe this is another testing resource issue with actually making sure G1 works well, specifically on the ARM32 platform. So I think it does work, and G1 is an option, but it's not going to be a supported option, and definitely not the default option on the platform. For small embedded devices, this actually probably isn't that much of a deal because you don't really want to spend a whole processor. The way G1 works is it does collections while the application's running, so it's slightly better because it's theoretically more pauseless, but then it eats up one of your processor threads or one of your processors in a multiprocessor system to do the garbage collection. So you constantly have background processes doing garbage collection. So you can use G1, but probably stick with CMS or one of the other garbage collectors on the small embedded devices. Okay, let's see, no fruit yet. How you guys feeling? Okay, there we got one guy in the back who's got a banana for me. Actually, I could use a banana. And all right, now here you can really lob it. Okay, so somewhere along the way in Java 8, we released JavaFX support. And that's going to continue in Java 9. There's no official JavaFX support. So Swing and AWT both work. They both work on all the way up to the latest version of Java 8. At some point in the middle of the Java 8 releases, I can't remember exactly which minor number, we dropped support for JavaFX, and you could only use Swing and AWT. So if you're doing anything with GUI or with screens, then this is challenging because Swing and AWT are much older toolkits. Like the monitoring system you were mentioning, what do you use for the UI for that? Okay, so you're using Swing, so you're okay. You'll still be able to run that. But if you want to upgrade it to JavaFX, it's more challenging. Ah, okay. So somebody was pointing out that the point of FX is to support make it easy to support multiple devices and operating systems and stuff. So why wouldn't we support ARM? That's an excellent question. I will. Yeah, that's an excellent question. I'll definitely ask the team. I think it's mainly a resource issue in terms of embedded platforms typically have different graphics chips, which are harder to support. So I know they spent a lot of time originally with bug fixing. It's basically an OpenGL stack at its core. So you can sit on top of different graphics architectures, but optimizing it for performance is hard. And also, it's yet another platform to test. So a lot of this goes in line with reducing the number of platforms which we have to test and certify Java on.
So is that still up for discussion, or that's like a permanent drop?
So it is probably something, if you guys feel strongly about, you should let us know. So you just did, and I think you are as well. But as of now, this is what's going to be shipped with 9. So unless somebody screams loudly, then this is what you'll get. So
Steve, can we put it to a vote?
All right, so we have a motion to vote. All right, so I usually don't like to do votes in my sessions because whenever you vote in the session, it's awkward. Have you ever been in you present, Brendan. Isn't it awkward when you ask people to vote and then people are like asleep and they don't want to vote and it's... Yeah, just don't do it, right? It's not a good practice. But for you, what's your name, man? Matthew. For Matthew, we're going to break the rule and we're actually going to do a vote here. All right, so everybody, let's start with the easy one. So everybody who they just don't care about JavaFX, they think it doesn't belong on embedded, it's like horrible technology. Okay, raise your hand. Who doesn't want JavaFX on embedded? Come on, be proud, raise your hands. There you go. Yeah. Okay. So, who thinks that possibly Steve and Oracle are making a decision by not putting JavaFX on embedded? Anyone think that? Maybe we're making a mistake? Just raise your hand. Okay. Yeah, okay. Maybe I'm making a mistake. Sorry. All right, sorry about that. Okay, so I do have some good news to go along with that. And our buddies at Gluon, does anyone know Gluon?
Just met.
Ah, okay, you just met them. So they're a Belgium company. They believe in this like weird thing called Wara. You guys heard of that? Write once, run anywhere. I think it's some legacy Sun concept. They're like stuck in the old Sun days. But they have like JavaFX running on iPhones and Android devices and Raspberry Pis, and they seem to think it should run everywhere. It's kind of weird. And on the downloads page for Gluon, you can actually pick your SDK, which you want to download. So they basically release free binaries, and then they also have their own features on top of it, which are kind of value-added services, which you can purchase from them. So they actually extend the platform a little bit with their own additions, and then they release the core functionality for free. And you can get an Android SDK, an iOS SDK, and an embedded SDK. And currently, this is the best way to run JavaFX on Raspberry Pi with Java 8. So if you're doing, like for example, for those screens you wanted to do, if you wanted to do some animations or effects with JavaFX, you could grab the Gluon JavaFX embedded SDK. There's instructions in their docs on how you can either have your application call it or link it in with the existing JVM on your application, on your device. And within like a half an hour, you're up and running with JavaFX in your application on small embedded devices. So it works well. I use this for my kids' workshops. We're actually using this for all the demos in the hub as well. If you've seen has anyone been to the Java hub yet? Okay, a few folks. We're going to fix that for everyone else soon. But that has lots of great examples of Java embedded technology. And they also ship Scene Builder. So do you guys know what Scene Builder is? Okay, a few folks in the room saying it. So Scene Builder is a drag and drop GUI builder for building JavaFX applications. Yeah. Yes, that's correct. So we don't support Scene Builder. But we open source the code base, and Gluon has continued development of Scene Builder. It creates FXML files. You can use these FXML files on your embedded devices for your desktop UIs. And we use this for all of the hub experience as well. So all the UIs running in the Java hub are also built using Scene Builder. And the cool thing about Scene Builder, a lot of the Swing GUI builders, they would have to generate code. And what's that one in NetBeans? Motif? Mati? I can't remember. It starts with an M. What? Matisse? Matisse. Yeah, that's it. So I believe that generates code, right? It spits code out at the end. But the problem with Swing and earlier toolkits is there wasn't a clean separation between code and design. And so with JavaFX, they fixed this. So this just spits out an XML file, an FXML file for the markup, and you can edit that offline. The code has a controller file which integrates with this, and you can communicate between the controller and the user interface pretty easily, so it's bidirectional. And it also gives you dependency injection. So if you're used to using that in your Java EE apps, this also supports DI. What that means is when you make changes to the UI, you don't break your code. When you make changes to your code, you don't break the UI. And you can actually have separate designers, but I mean, just as an individual programmer, this is wonderful because you're no longer worrying about, like, did I make a change to the auto-generated UI code such that it won't open in the editor anymore? It always works. So anyway, Gluon's doing really cool stuff. Check out their site, support them. It's a really small company. The founders are Java champions and folks who are really passionate about JavaFX technology. So give them all hands. And you can see their community app in the store at gluonhq.com/java1. So this is actually and if you're taking a picture of the screen, don't. Download the app on your phone. What do you have a phone for? So go here to this URL and download, or the easier way is in the App Store, either the Play Store or the iOS Store, just type in Java 1.16. and that'll get you the Gluon app will come up. Or even searching for Java 1, besides the official app, it's the second one in the menu. Okay, so anyway, they built this entirely in JavaFX technology. I'm sure it would run on embedded too if you wanted to run it there. And
It runs better than the official.
okay, so we have somebody who says it runs better than the official one. Yeah, so as an official representative of the Oracle events team, I would have to say we're very disappointed that you don't like our official application, and we're going to attempt to approve it. Thank you for the feedback. Yeah. Okay, so let's do a little demo action. So we got our Makeblock line runner, who we wanted to get to run around the stage a little bit. This guy is one of the projects from the Raspberry Pi with Java book, which I wrote. And he's got some fun sensors on it. While we're talking, I'm gonna see if I can't bring him to life. Doop, doop. Okay, so the question was, do I have the design online? I believe the answer is yes. Okay, so this is actually all the parts for it. So I did an early, well, okay, so I have all the code online. So you can see all of the code for running this in my GitHub repo for the book. So if you just look for Raspberry Pi with Java, you'll see the full GitHub repo with the code. The hardware and the parts are from a company called Makeblock in Hong Kong. And they have this cool thing with these extruded aluminum things. So this is kind of like Legos for big kids. So what they've done is they've basically taken this idea. They found out about this in an assembly plant where one of the workers had created these ridged grooves in extruded aluminum, and then they could screw into it at any point. Because they just put straight vertical grooves here, and then you can use those as screw treads to screw in, and it's extremely tight. Even though it's only holding from two sides, you can get really strong connections. So between that and the holes on all the different sides of this, you can really orient and screw things together quite tightly and quickly. So normally, if you had a demo, you wouldn't just toss it around. But it's a really robust demo. You can just fling it around, and it's quite good. And the full build for it, picture by picture, is in the book, Raspberry Pi with Java. So if you want more detailed instructions than code and kind of hardware, then you can follow the instructions of the book and try to replicate it exactly. Okay, and I'm also going to give this guy a little Wi-Fi access point. He is running Java 9. So what we've got going on him is we have some GPIO code using Py4j. The Py4j library is a really great open source library for doing access on GPIO pins. It supports straight GPIO turning on and off. It supports doing things with small analog to digital boards, SPI interface, I2C devices. You can even do one-wire stuff with it, or I think that's a coming feature is one-wire support. But there's just a huge breadth of hardware which the library supports. And the guy who built this, Robert Savage, is a really cool guy as well. So he's an embedded hardware hacker himself. It sits on top of the Wiring Pi library, and it works on the latest version of Raspberry Pi. So it works all the way up to Raspberry Pi 3s and 0s. So he's been doing a really good job keeping up the code base. And here you can see the line follower. So it's pulling 2 pins for the line follower. And based on whether the sensors see white or black, it will change the direction of the robot with a very simple algorithm to try to stay on the line. All right, so for our folks in the audience who are good at theorizing on algorithms, what do you think happens when our robot hits a cross in the road? Anyone want to take a guess? Okay, so somebody said it stops. It what? Spins? Maybe it spins in a circle. Reverse? Okay. Those are all really good guesses because I don't know the answer. But we're gonna find out hopefully and see what happens. Okay, so miraculously, this never happens with hardware demos. Miraculously, I'm in the robot now. And you can see my mess of a file system, but we should have a JDK build is here as well. JDK 9. We have Java. Okay, so we're running the early access release of Java 9, the same one you can download straight off the Java 9 website, the OpenJDK 9 website. Choose the 32-bit version when you download it. Even though the Raspberry Pi 3 is technically a 64-bit architecture, they still compile Raspbian for 32-bit OSs, so you still want the 32-bit version. I'm gonna let you in a secret. I don't think jshell actually works. Let's try it. And while we're doing that, because I think it's going to just horribly fail, we'll open a second prompt up. Okay, let's see how we're doing. Okay, yeah, we're not doing that good. So you can tell this is beta software. Oh, we got something. Oh, okay, this is good. Let's see. Please, maybe. Yes, all right. Working jshell. So you can load libraries and do more interesting things, but I'm not going to push the demo gods anymore. Let's get to our favorite little robot. Okay, so you can run things directly on the command line here, but what I'd actually recommend is using IDE integration. And you can do this in IntelliJ. You can also do it in NetBeans. NetBeans has built-in support. IntelliJ, there's a Raspberry Pi plugin that you can use. And for somebody who's an Eclipse guru, they probably know the appropriate plugin for that as well. But remote debugging on your device is really the way to go. So in NetBeans, the way you do it, and you can see all my little different platforms for different Raspberry Pis I play with at home. You add platform, choose a remote Java Standard Edition, go next, tell it you're, I want to create a test platform. My host name, username, password. Okay, and this one's a little tricky. The remote JRE path on devices is difficult to figure out. So in this case, we're going to point it to the Java 9 directory, which is just home pi JDK 9. And if you try this at home, it will fail, and you'll notice it fails. Maybe it works. Maybe it fails. Oh, it worked. Okay. There you go. So things I don't think should work are working all the time now. This is the opposite of how it's supposed to work on stage. All right, so we got our test platform. And now what you can do inside of your project is you can just go to one of your many projects and then choose properties. And under run, you have to create a new configuration. You can't be on default. And once you have a new configuration, you can choose your test platform. All right, so you guys believe I should be running on Java 9 now, right? We picked the JDK. We saw it all hooked up properly. We even checked the command line. Let's give our line runner a try. All right, so I'm gonna start here. We'll get a little bit of, hopefully a little bit of working room now. Sudo. Okay. This is another good trick. So a lot of the libraries require root access, like Pi4j requires root access. There's a way to work around that. There's another mode in Py4j where it can go through the file system, which doesn't require root access, but your GPIO performance is slower. So just give it root. It's faster. You'll be happier. So go to Java platforms, and the trick is an exec prefix, type sudo, and then hopefully we're better now. No. Oh. Did I not save it or something? Something silly? I'm getting all my good karmas disappearing for testing things. Test platform. I didn't? No. Run. Yeah, I'm on that. Test platform. Yeah, I mean, I don't know. Yeah, the directory has an extra slash. It doesn't matter. Okay, so it worked this time. It didn't work last time. So I guess the trick is you wait longer or you try it twice. All right, so we're gonna see if we can get this guy to go. Oh. All right, and what's rule number 1? Yeah, you don't have to sit down. Okay, so our little buddy is going good. Now, we also have a sensor on the front of him, which is designed to do obstacle avoidance. So somebody needs to stand in front of him. Stick your foot in front. Come on. Foot. Ah, okay, it works. So that's a safety feature, but it's using that optical sensor on top. Oh, come on, you can do it. Yeah, made it. I have the motors here at half power, which I think that's not good enough. This is a little boring, right? Do we want to make him go? Oh, how's he doing on the turn there? Oh, he saw the turn and he got scared of it. All right, so we're gonna speed him up because this is silly that he's going that slow. Hold on. So he uses pulse width modulation for the motors, and so I have different speeds in the code, and we're gonna see if we can't have him be super fast rather than super slow. Okay, let's see. Where's our motor director, line follower? Oh, yeah. That's because I killed the program and one of the motors kept running. But that's okay. We're gonna make him go faster. Here we go. Change speed. Stick it here. Let's see what I pass into this. Okay, I guess we do this one. Oh man, this is hard to see. Hold on. Okay, we'll make him speed up twice. Okay, so I want to just start him. All right, let me make my way back to the guy. So when he finally wakes up, he should be going a little bit faster. Oh yeah. All right, so let's see what happens to the line when he hits it this time. Okay, so this is running full speed. You see he has less trouble on the curves. So the pulse width modulation, it does two things. It slows it down, and it also reduces the power to the motors. Is that hitting like a little? Oh, I see it. Yeah. It's getting stuck on that little section, but bump. Oh, there we go. Oh, he made it.
How is it deciding at the cross section?
I don't think it was deciding. I think it blew through it. Yeah. Oh, he made it through that one too. All right, so crosses do work. All right, so our design team did an excellent job on the track. Give them a round of applause. All right, so that's a quick example of what you guys can do. But I have more examples too I want to show you. And there's a small problem with that. They took all my hardware and they stuck it in the Java hub. So oh, and here's my boop-a-doo. So who wants to go on a field trip? Anyone in for a field trip? Yeah, more. Okay. So let me explain to you how this works. So we're not supposed to be in the Java hub right now. It is closed. But we're going to go there anyway. And there's a bunch of technology demos there. So we have a CNC router, which happens to be hooked up to a Raspberry Pi. We have an embroidery machine, which happens to be hooked up to a Raspberry Pi. We have, what else do we have there? Oh, we have the RetroPie gaming device, which is a 3D printed Raspberry Pi gaming device. So we're gonna sneak into the hub early. I'm gonna force them to let us all in, whoever wants to come on the field trip. And I'll show you guys the demos there. And that way we also don't get disturbed because none of the other attendees, they're all going to be busy in sessions, like, you know, listening quietly, watching the bullet points, reading the bullet points, and we'll be having fun over there. So you don't have to come on the field trip if you have something else you'd like to do. Oh, there's one more example of technology as well. So the voting machines outside, they're also powered off of a JavaFX user interface and a Raspberry Pi in the back. So on their way out, I'd recommend that you test the voting machine. We're not going to be coming back. Yeah. Yeah, so this book, it actually has a blue cover. I didn't fix the cover, but it is in the bookstore if you want to purchase this one. OK, so whoever wants to come in the field trip, hang out for like 2 minutes while I pack up, and pack up yourself as well. We're not going to come back to the room. So if you want to do voting, do it now. Play with the voting machine now. Then we'll do a little line over to the hub, and I'll walk you guys through the experiences and then explain how those use Java technology behind the scenes. For everybody who doesn't want to come on the field trip, thank you very much for coming to the session, and I hope you learned a little bit about Raspberry Pi and Java 9.